Experiment 1. Aim. To study the dependence of potential difference, V, across a resistor on the current, I, passing through it and determine its resistance. Also plot a graph between V and I. Materials required. An insulated copper wire, cut into 10 pieces. Key. Ammeter. Battery. Voltmeter. Rheostat. Resistor and a piece of sandpaper. Theory. Ohm's law, the potential difference, V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains same. V is equal to IR. Here R is the constant of proportionality, I the resistance of the conductor. The C unit of potential difference V is volt. C unit of resistance R is ohm. 1 ohm, if the potential difference across the ends of a conductor is 1 volt and the current flowing through it is 1 ampere, then the resistance of the conductor R is 1 ohm. 1 ohm is equal to 1 volt 1 ampere. Circuit diagram. R is equal to resistor. B is equal to battery. K is equal to key. A is equal to ammeter. V is equal to voltmeter. RH is equal to rheostat. In a circuit, ammeter is always connected in series and voltmeter is connected in parallel across the points between which potential difference is to be measured. A straight line graph attained between V and I verifies the Ohm's law. Least count. It is very important to find the least count of ammeter and voltmeter before using them. If in the ammeter, there are 10 divisions from 0 to 0.1, then each division indicates 0.01 A. To calculate the least count of ammeter. Range of ammeter is equal to AR. Number of divisions in ammeter is equal to AN. Least count of ammeter is equal to AR upon AN. B. To calculate the least count of voltmeter. Range of voltmeter is equal to VR. Number of divisions in voltmeter is equal to Vn. Least count of voltmeter is equal to VR upon Vn. Procedure. 1. Set the devices as mentioned in the setup. 2. Connect them with the connecting wires and put the key open. 3. Positive terminal of the battery is connected to the positive terminal of the ammeter. 4. Check the positive VE and negative VE terminals of voltmeter before connecting it in the circuit. 5. When the circuit is connected, insert the key and check the rheostat, adjust its slider, and see whether there is any deflection in needles of ammeter and voltmeter. 6. By using the slider of rheostat, take 3 different readings of current I and voltmeter V. 7. Note your observations in the observation table. 8. Calculate resistance of a given resistor by using the formula. 9. Plot a graph of voltmeter reading and current reading. Take V on x-axis and I on y-axis. 10. Resistance increases with increase in temperature of pure metals. Observation and calculations. Least count of ammeter is equal to ampere. Least count of the voltmeter is equal to volt. Range of the ammeter is equal to ampere. Range of the voltmeter is equal to volt. Zero error of the ammeter is equal to ampere. Zero error of the voltmeter is equal to volt. Observation table. On the basis of above procedure, complete the following observation table given below. Graph. Verification of Ohm's law. On the basis of above procedure, complete the following observation table given below. Result and conclusion. The value of R is found to be same and constant in all three readings. The resistance of a resistor is ratio of potential difference V and current I. The graph of V and I is a straight line. This represents that V direct proportion I, hence, it verifies Ohm's law. Precautionary measures. 1. The connecting wires should be thick copper wires, and the insulation of their ends should be removed using the sandpaper. 2. Connections should be tight, otherwise some external resistance may introduce into the circuit. 3. Connections should be made as per the circuit. 4. The ammeter should be connected in series with the resistor in such a way that the current enters at the positive terminal and leaves at the negative terminal of the ammeter. 5. Voltmeter should always be connected in parallel to the resistor. 6. Calculate the least count of voltmeter and ammeter correctly. 7. The pointers of the ammeter and voltmeter should be at 0 mark when no current is flowing through the circuit. 8. Current should be passed through the circuit for a short time while taking observations. Otherwise, excess of current would cause unnecessary heating in the circuit. Heating may change the resistance of the resistors.